Greetings, Algonauts. Algorand recently released news of a network upgrade that expands smart contract functionality with contract-to-contract calls. Also, they're releasing post-quantum secure keys for trustless cross-chain interoperability. Today, I want to dive into the contract-to-contract calls. Anne Kenyon, a product manager from Algorand, has graced us with a Medium article giving us multiple use cases for contract-to-contract calling, also explaining some of the tech behind it. I am going to do my best to summarize the use cases. However, if I get something wrong or if you have more insight on how we can use this feature, please feel free to comment down below. In the first use case, Anne talks about getting the best deal for a swap. There are multiple AMMs on Algorand. For example, we have Tiny Man, we have WagMe Swap, we have PacFi, Humble Swap will soon go on mainnet. So how do we know which AMM is going to offer us the best swap deal? The prices are constantly fluctuating on AMMs just depending on the ratio of the liquidity. So in this use case, Anne says that, hey, you can write a smart contract that will check all the rates at the different AMMs and then actually call the contract and swap on the best rate. And then that will happen all on chain. So this is just an example on how you can get the best rate on swapping without going to each of these dexes and looking at it manually. By the time you do that, the rate could have changed. And the second example is safety checking your applications. In this use case, there's a user, Elijah, who doesn't necessarily trust using a specific AMM, and I think we all can relate to that. Crypto is the wild, wild west, so we always want to, make sure that we're taking precaution when we're using a new tool. So in this case, Elijah writes a smart contract using an assert statement to confirm that he is going to receive the expected amount of ALGO that he wants in a specific swap. If the assert fails, the entire smart contract fails and everything is rolled back, including the call to the AMM. If it passes, the code guarantees that he has received what he is expected to get. The third use case is using other contracts. In this example, she discusses an NFT marketplace that allows buyers to pay using USDC or ALGO, and sellers to either receive their payment in USDC or ALGO. In this example, a buyer wants to purchase an NFT and pay in ALGO. However, the seller wants to receive their payment in USDC. So what happens is that the NFT marketplace does a contract call to an AMM once they receive the ALGO from the buyer, and then swaps that for USDC and give the USDC to the seller. This is pretty neat because the NFT marketplace didn't have to write their own contract to do the swap. They were able to just go to a third party and use a contract that already existed. In the next section, Anne goes into specifics around contract-to-contract calling. In the third example, where the NFT marketplace calls the contract from an AMM to swap the ALGO for the USDC, that is called an inner transaction, since the transaction initiated from inside of their smart contract. It is possible for these inner transactions to call another contract. So I'm wondering if the NFT marketplace could call the contract in example 1 and actually find the best rate for the swap. Another thing that she mentions is that just remember that each transaction on the Algorand blockchain does have a minimum fee of 0.001 ALGO. So for this particular example, there will at least be a fee of 0.003 ALGO. She also goes into just some more details that developers need to consider when they are developing their apps. The moral of the story for me is that I need to learn how to code. If you have any recommendations on courses for writing smart contracts, please leave a comment below. Or if you plan to use some of this functionality to write a smart contract, please comment below. Thanks for tuning in.